Hey everybody, thank you for checking out A1 Math. And today we're talking about identifying a function's domain, range, and end behavior from its graph. Okay, so before we get into that, I want to really talk about what domain and range are. Okay, so if you have a number line, and a lot of people remember it as X and Y, as you put in values for X, you'll get values for Y. Okay. All the values you have for X are your domain, and all the values you have for Y is your range. So that's what that is. So to clear it up, domain of a function is function f is the set of input values for X, and the range is the set of fx values for the output. Now, the end behavior of a function describes what happens to f of x as x increases without bound or decreases without bounds. Okay, so as x goes to positive infinity, what happens to y? And as x goes to negative infinity, what happens to y or f of x? So usually the symbols for that is as shown here. You have as x goes to positive infinity, what happens to f of x? And as x goes to negative infinity, what happens to f of x? All right, so let's take a look at an example. All right, now the first thing we want to do is list the domain. So there's three ways to list it: inequality, set notation, interval notation. Same thing for the range. And then the next thing we're going to do is find the end behavior as x goes to infinity and negative infinity. Now, since I have this graph here, I could tell all my values for x. Um, if you go from 0 and go left to right, x goes on forever this way based on the arrow, and it goes on forever this way based on the arrow going up. And that's going left and right. So the inequality, which is the x values, is x is going to be greater than negative infinity, but less than positive infinity. The set notations, which is similar to the inequality, is um, x such that x is greater than negative infinity, but less than positive infinity. And the interval notation will have two parentheses with a negative infinity and a positive infinity. Okay, now we're going to take a look and see what happens with the y. Now, with y, the range, um, y goes up and down. Now, as we go from 0 and go up, we could tell that y is going to continue on forever, so it's going to be infinity that way. But as we go from about 0 coming down, we could tell that this line is not going across the x-axis. So it's not going below that. It's not going to be negative. So it's going to come to or come close to one specific y value, which is 0. So the y values, which is the range, it's going to be y is greater than 0. So y is going to be greater than 0 all the way up here, but not going to be less than 0. The set notation, which is similar, is going to be y such that y is greater than 0. And now for the interval notation. The interval notation um, has a parentheses because it's not going to include 0 on the left, and on the right, it's going all the way up to infinity. So that's the domain, range, and end behavior. Now, well, domain and range. Now we're about to do the end behavior. So as x goes to infinity, what happens to the y? Well, as x keeps going this way, y goes to positive infinity. So that's going to get us f of x goes to infinity, or y goes to infinity. Next, and this should say negative, but as f of x goes to negative infinity, going to the left, y gets closer and closer and closer to 0. Okay, so that's the domain, range, and end behavior. Okay, take a look at this one and see if you can get it. Okay, now on this one, the answer for the domain is this. The range here, and the end behavior here. Okay, and that's as x goes to negative infinity, f of x goes to negative infinity. Keeps going this way. And as x goes to positive infinity, f of x goes to negative infinity. Keeps going this way. Okay, now here's another example of a different domain and range problem. What we want to do is take the function that's already given to us and find, and it's also give us a domain where it's going to stop and start it. And what we want to do is graft it based on this and then figure out what the range is going to be. So let's take a look at number 9. So number 9, they give us the negative 6 is less than or equal to x, and x is less than 2. So we know it's going to go to negative 6 on the x-axis and include that point and go to 2 on the x-axis and not include that point. But we don't know what the point is going to be based on the function. We need to plug in these values to figure that out. So the first thing I want to do is plug in this negative 6 into our function. So negative 6 times a negative 1/2 is going to give me a positive 3. And the positive 3 plus 2 is going to give me 5. So my first point is going to be negative 6, positive 5. So I go over 6 and up 5, and I put a closed in dot. Okay. Now the next thing I'm going to do is go ahead and plug in my 2 into the same function. And when I plug in my 2, I'll get negative 1 plus 2, which is 1. So my coordinate is going to be over 2 and up 1. And it's going to be an open circle because of my inequality doesn't have an equal then. Okay. Now I've figured out what I needed to do to graph it. The next thing I need to do is figure out what the range is going to be. Well, the range is going to be up and down for the y. So going up, the range is going to be as high as 5. But going down, it's going to go as low as 1, between 5 and 1. And since I have a set notation, or I'm sorry, a inequality for my um, notation, I'm going to use an inequality to describe the range. So the range is going to be where y is in the middle, but it is going to be greater than 1, but less than or equal to 5. Less than or equal to 5. Okay. Now to recap, what we've done here is we talked about domain and range when given a function as a graph and finding the domain and range. We also talked about um, having the actual function without the graph, given the domain and being able to graph and find the range. And I hope this was helpful. Thank you for checking out A1 Math.